Good morning, good afternoon, and good evening to everyone. Dear authors and invited guests, welcome to Technical Session 6A. I'm Sanskriti Kamkar, and I will be moderating this session. On behalf of the Global Knowledge Research Foundation and GIA Scholastic, it is my pleasure to welcome you to the 11th International Congress on Information and Communication Technology, ICICT 2026, London, UK. This edition of the conference is being conducted in a hybrid mode. The physical event was held yesterday in London, and the virtual sessions are being conducted via Zoom from 25th to 27th February 2026. I hope you find today's session engaging, informative, and insightful. In this session, we have 5 presentations. Each presenter will have 12 minutes for their presentation, followed by 3 minutes for questions and answers. I will give a gentle reminder when 2 minutes remain. I request all participants to stay connected until the closing remarks. If you have any questions or updates, feel free to share them in the chat box. I would also like to apologize in advance for any mispronunciation of names during the session. Before we begin, I'd like to introduce our session chair, Dr. Amita Sharma, Assistant Professor, Selection Grade in the Department of Computer Science and IT at IIS, Jaipur, with over 13 years of teaching experience. Her areas of interest include software engineering, networking and security, data mining, and knowledge discovery, database systems, web services, and the integration of Vedic science with modern theories. Now, would you please like to share a few words with us?
Thank you so much, Sanskriti. It is really always a great pleasure to be a part of GIA Foundation conferences, and I'm looking ahead to see some more fruitful discussion in this session. All the best. Thank you.
Thank you, ma'am. Now, with such encouraging words, let's proceed with the presentations. Our first presenter is Asmita Shinde. She will be presenting a comparative study of stress and its effect on work performance of female employees in higher education institutions in rural and metropolitan areas, with special reference to Wardha and Nagpur districts. I believe that she's absent, so let's move on to the next presenter. Our next author is Rui Lima, presenting their paper on contribution evaluation of frailty in the elderly and approach towards improved geriatric care.
Hello. So can I share my... Sorry?
Yes, you are audible. You can share your screen.
Yeah, thank you. Yeah, I was going to ask if I can share my screen. Okay, I don't know if you are seeing my first slide.
Yes,
Yes,
it is.
it's visible.
Okay. So first of all, thank you very much. Good afternoon, and thank you for being here today. So my name is Rui Lima, and it's a pleasure to present our work entitled Contribution Evaluation of Frailty in the Elderly, an approach towards improved geriatric care. In this research, we propose an interdisciplinary framework that combines geriatric healthcare thermodynamics and logic programming to a model uncertainty and frailty assessment. So our goal is not only to evaluate frailty, but to structure how it is perceived and interpreted within institutional decision-making systems. I will begin by briefly framing the problem of frailty in modern healthcare. Then I will introduce the computational and thermodynamic framework supporting our approach. After, I will present the evaluation of frailty in elderly population, an empirical study, and explain how entropy was computed. And finally, I will discuss results, governance implications, and future research directions. So frailty is a multidimensional condition characterized by reduced physiological reserve and increased vulnerability. So it significantly raises the risk of hospitalization, institutionalization, disability, and mortality. However, despite validated tools such as frailty index and the frailty phenotype, fertility assessment is still inconsistently integrated into routine clinical workflows. This creates variability in perception, interpretation, and decision-making. So globally, aging populations are increasing healthcare system pressure. So the challenge is not only clinical complexity, but also decision uncertainty. When uncertainty is unmatched, resource allocation becomes reactive rather than strategic. Therefore, improving frailty assessment is not only a clinical goal, it is a governance priority. So we need tools that transform subjective perception into measurable information states. To structure uncertainty, we rely on knowledge representing and reasoning, particularly logic programming. Our approach uses a proof-theoretic framework with extended clauses, strong negation, and negation by failure. This allows us to formally represent both explicit knowledge and informal gaps. In short, we move from subjective perception to computationally interpretable structure. We reinterpret informational states through a thermodynamic lens. Just as physical systems distribute energy, cognitive systems distribute information. So we define three information's energetic states: exergy, vagueness, and anergy. Exergy structure, usable knowledge supporting decision making. Vagueness, we don't know, it's ambiguous, it's informal states. And anergy is a potential that exists but not operationalized. So the balance between these states defines the system's entropic state. Lower entropy reflects greater structural coherence. Higher entropy reflects dispersion and uncertainty. So the level of evaluation of frailty in elderly population study was designed to evaluate uncertainty and frailty assessment practices within institutional settings. Rather than measuring patients directly, we measure professional perception and integration maturity. So the empirical study named EFAP was conducted between May and October of 2025. I will explain after here. We are empirical study conducted between May and October, like I said, 35 gerontologists invited to participate, 120 fully completed questionnaires, and participants from small to medium healthcare institutions. So the questionnaire was divided into 4 structured instruments: frailty identification and integration, quality level of life and healthcare utilization, proactive person-centered care, and outcomes and future directions. I will show the different questions that we posed in the 4 groups. We have 3 questions for the first group, so S1, S2, and S3. And for questions, for instance, has your institution adopted a standardized method for identifying frailty in elderly patients? For instance, S3, have you noticed any changes in the quality of geriatric care since the integration of frailty assessment. In the second group, I am going to give just an example. S6 has routine frailty assessment impacting hospitalization rates or lengths, and so on. We have another group of 4 questions, and finally the last 4 questions, and I will say the S15, how does your institution plan to further develop the use of frailty assessments in geriatric care? So after that, we have this complex table. So in order to quantify the qualitative information collected and make the process intelligible, we complete the calculation details and we provide this calculation. So this table details 15 operation statements. Across 6-month observation period, the same professional responses are tracked longitudinally. So this allows us to capture informational drift, stabilization, or restructuring over time. So a gerontologist responded to questionnaires, the 4 groups across 6 months. And here we have an example of a response to the questionnaire. So for instance, the answer number 9, the physician, respond 4 and 3. So it means sometimes he strongly agree, but there are sometimes he only agree. So it indicates that the sentence does not reject the possibility to that he only agree in certain situations. That's the tricky questions, and that's how we are going to be able to calculate the uncertainty. Okay. Now another example that we have here. So the answer is S2, he disagree, but sometimes he agree. Shows a trend in the development of the system with a decrease in entropy. In terms of the calculations, as we said, we move from the theoretical modeling to the empirical results. At this stage, we compute exergy, vagueness, and energy for each questionnaire. So here we can see the graphical interpretation of participants' responses. The darker area represents the exergy, structured knowledge. The gray area corresponds to vagueness, and the white corresponds to the energy. It's the visual decomposition helps to illustrate how informational energy is distributed at the given time. So here we have we can analyze the energetic informational states derived from the formal equations. So the 6 months aggregation allows us to observe systemic informational behavior rather than isolated responses. So this comparison provides a measurable uncertainty interval, what we conceptualize as the entropy bandwidth of institutional perception. Finally, the entropic states, or ES, is calculated. So as results of energetic decomposition of responses, we have here a progressive reduction of entropy values, increased proportion of structured information energy, and decrease in ambiguous or undefined responses. So the stabilization of institutional perception is very important here. The longitudinal entropy trajectory demonstrates a gradual transition from informational dispersion towards systemic coherence, indicating that frailty assessment practices become progressively more structured and integrated within institutional decision-making process. So the relevance of this framework extends beyond measurement by operationalizing uncertainty through entropy computation. We provide healthcare managers with a structured decision-making support instrument. So practically, this supports risk-aware decision-making and improves prioritization of vulnerable patients and enables institutional benchmarking. Most importantly, it aligns frailty management with sustainability and governance objectives. So this research proposed a reframing of frailty. Frailty is both a clinical and an informational phenomenon. So by modeling it is an entropic construct, we enable measurable uncertainty quantification. Logic programming ensures that we can prevent black box opacity and longitudinal entropy, monitoring strengths, institutional resilience. Finally, this approach moves geriatric assessment by honed descriptive categorization toward computational validated decision support mechanisms. So in the future research, we'll focus on those main directions. First, correlating entropy metrics with objective clinical outcomes. This will validate whether informational stabilization and translates it into measurable healthcare improvements. Second, multi-center scalability validation. So we aim to test the model across diverse institutional settings to assess generalizity. Third, integration with AI-based predictive systems and real-time digital health platforms. So finally, understanding frailty means understanding vulnerability. And understanding vulnerability means understanding the future we are collectively moving toward. As population age, informational coherence in care systems becomes a society necessity. So this work is a step toward transforming uncertainty into structured governance. So thank you for your attention.
Thank you. It is really a wonderful presentation, and it is my first time I have listen about the talk which uses thermodynamic model or approach in health context, which is a really a good thought of approach to this kind of problem. The only concern is it really possible, or in real time we can receive such a data as well as tracking of data of specifically such patients? Won't be it will be a difficult task for continuously monitoring and getting data and then applying this model. What do you think? How what is the success rate of such model if we talk about in real aspect?
So in my opinion, what we can do, because it's very linked to the chaos theory. So let me explain. We have here 4 groups of questions, and after that we can go deeper and deeper and deeper to analyze what is expecting, or what are we expecting from our patients, in order to know and to prevent where are they going to be more exposed to frailty. And in order to have those data, after some input of those data in our logic program computer, we are going to be able, in some aspects, to know where they are going to shift. I mean, they are going to some critical points that will be identified, and that will allow us to make a prediction where are they going to shift, and where are they going to be a problem to be solved before having a problem.
Okay. And one more thing which I just find, if we don't use entropy model, because again the question is continuous collection of data and then taking it to real time is a challenge with this kind of entropy model. If we don't use entropy model, what kind of model do you think will be more suitable? Or if we can design some hybrid model for such problem, what is your say in that?
Yeah, I think it is possible. Our idea of this approach of entropic model is that it's a way to quantify the grade of energy that is available to use, or the
Yes.
energy that we already don't have. It's a way just to have a number, because
Okay.
we have so many questions, and to give a number to those questions, to quantify those questions, it's not easy. So it's a way, it's an approach to know how much energy do we will still have to spend. For instance, when we born, we have every energy to spend. So in that phase, our exergy is 0, and we have a lot of energy to spend. And when we die, our exergy is 1. So we don't have more energy to spend. So the goal is to know where we are and how much energy do we have to spend.
It's more like a fuzzy set where we
Yes,
are just in between
yes,
0 and 1.
yes, for sure.
Really, it is a wonderful presentation and wonderful research work. Thank
Thank
you
you
so
very much.
much.
Thank you so much. Thank you so much.
Thank you, Ms. Lima and Dr. Sharma, for this engaging and insightful conversation and discussion. Next up, we have Muna Bazazi presenting CM onto domain ontology for computational thinking.
Thank you, ma'am. Well, I'm very excited and delighted to present my work for this conference. I'll share my screen.
It's visible. You may start with the presentation. Could you please unmute yourself? We can't hear you.
Does it work now?
Yes, you're
Hello?
audible.
Sorry, it was problem with my micro.
That's okay.
So I'll start again.
Yes.
Okay, thank you. So I'm very delighted to present my untitled paper, City Onto Domain Ontology for Computational Thinking. It was realized by me under the supervision of my professor, Kauthar Nwira. During my presentation, I'll start with an introduction of computational thinking, then I'll move to the context and motivation of this paper. After that, I'll present some related works, and after that, I'll present my contribution, City Onto Domain Ontology for the field computational thinking, and I'll conclude with the conclusion and the future direction. So before we start, we have to know what is computational thinking. It is a new field that dates back to the 1980s. It started with the pioneer and computer scientist Seymour Papert. So this field, it was known for the problem-solving method. It enables breaking down complex problems. It is based on the use of logic, algorithms, and conceptual understanding. And after that, it was revived in 2006 by the computer scientist Janet Wing, when she stated that computational thinking is not just for computer scientists, but it is for everyone. And after that, this field started to be very attractive to all computer scientist researchers, which result different and various viewpoints. And with the increased number of the proposed definitions, there is the appearance of new concepts, new terminologies linked to this field, which motivate us to look for how to conceptualize all these terms linked to this field. And we have noticed that there is a lack of shared conceptual foundations, where the absence of a common vocabulary and shared knowledge structure hinders effective communication among researchers and educators. As I mentioned, that there is no agreement between them about what is computational thinking, how we will define this field, and what are the principal keywords and terminologies that we should use to present the field of computational thinking, or the term computational thinking, because it is known as a field and as terms. So there is a need also to clear what is this field and what are the principal linked concepts. Moving to the second motivation, which there is a lack of conceptual alignments with the comparison of the studies of researchers, and there is a need also to integrate and synthesize research results. And the researchers and educators often use different terminology to describe similar concepts, complicating cumulative knowledge building, according to the work of Lampro and Ripening in 2018. And according to Abdelhamid et al. In 2025, computational thinking definitions continue to evolve and vary across studies, and where each researcher propose a definition and define computational thinking in his own viewpoint and according to his research field. Well, this evolution lead the researchers generally to conceptual the inconsistency. There is a proliferation of related but inconsistently defined concepts. There is a need for a comprehensive collection and consolidation of CT-related terms. I'll prepare a comparison between the proposed ontologies of computational thinking, where the work of Brennan and Resnick, they focus just on conceptual framework for computational thinking, where their contribution is to structure computational thinking into three main concepts: the use of general concepts, the practice, and there is the perspectives. Well, the limit of this work is that there is no formal semantic or machine processable representation. And for the work published by ESTA, they focus just on K-12 computational thinking education, in which they identify a key of CT component for schools. They focus just on the terms linked to computational thinking and education for the level K-12. Where their limitation, there is a lack of conceptual terms, and there is lack also of formal modeling. And moving to the third work of Sosnovsky and Desheva, where they focus only on proposing an ontology for programming, and their contribution is it was the proposition of ontology of computer programming concepts. Well, the limit of this work is that they cover just only a subset of computational thinking. And moving to the work of Araujo et al., they focus on computational thinking and programming education, in which their contribution was to define an ontology for computational thinking and programming concepts for school, in which they mentioned just the concept, the main concept of computational thinking, and this and their use in education. So the limit, just they focus mainly on programming context. And for the work of Kelly and Giro, they focus on defining or specifying computational thinking versus design thinking. Their contribution was a proposal of ontology that clarify relationship between computational thinking and design thinking. And the limitation of this work is that there is not model computational thinking as a complete domain. So after studying all these work that they focus on proposing the ontology for computational thinking, there is no work that that present a global domain ontology for computational thinking that conceptualize all the terms linked to this field. So our contribution is the proposition of domain ontology for computational thinking. But before start presenting this ontology, we have to understand what is the domain ontology, in which, according to Grover and Garino, an ontology is an explicit specification of a conceptualization, and it is composed of an intentional vocabulary linked to a specific domain of reality. It is explicit assumption expressed in first-order logic, and also according to the work of Natasha Noy, Maginez et al. In 21, an ontology is a formal explicit description of concepts in a domain of discourse, classes, property, describing features and attribute of concepts, such as slow or roll, and restriction of these property, what we call facet. So to elaborate our domain ontology for computational thinking, we have collected 288 research paper, articles, and conference papers. And after that, we just work on the articles that are published in journals, and we specify the type of journals in which they are ranked key one. And we have collected 685 terms, including singular and plural variation of verbs forms.
Excuse me.
And
I'm sorry to interrupt you.
Yeah.
This is just a gentle reminder that you have 2 minutes remaining.
Okay, thank you. So to prepare our domain ontology, we extract some potential classes, potential attributes, potential instances, and potential relations. And we eliminate the stop words, or what we call ambiguous terms. So our domain ontology was based on the methodology Mac, Guinness, Noy et al., which enable us to reuse an existing ontology to elaborate a new one. And the existing ontology that was the basis of our domain ontology is the work of Araujo et al. This is minimized the domain ontology for the field computational thinking. And after that, we evaluate and so we evaluate our domain ontology after an expert evaluation. And also, we use these tools, Hermit Reasoner and Sparkle queries, to evaluate the performance in which we detect unused and redundant ontology classes. We identify the potential logical inconsistency. And after that, we have used the Sparkle query that is used to retrieve classes declared with no associated instances. And we have also extracted the anonymous classes. This is the Sparkle query that enable us to extract the unused concept identification. And after that, we have used the Sparkle query to detect instances belonging to disjoint classes, and the results appear only if the ontology is not already flagged in as inconsistent, and it supports ontology debugging and validation, as shown is this figure. And we have compared our proposed ontology with the existing one. And our ontology, it offers an extensible framework that clarifies conceptual and pedagogical ambiguity and supports computational thinking abstraction directly. Our key role of this ontology, it organizes knowledge in computational thinking. It serves as a valuable tool for educators, researchers, and policymakers. It enables linking computational thinking to levels of abstraction, problem solving, and critical thinking, which are the main a part of main concepts of computational thinking. It is a function. It functions as both a scholarly resource and a practical tool for promoting computational thinking abstraction. And so this paper introduced the domain ontology for computational thinking. We labeled CT-ONTO, a formal domain ontology dedicated to computational thinking. It aims to establish a shared semantic foundation for CT research and education, and also it addresses the lack of semantic formalization found in existing conceptual frameworks. Our domain ontology supports organizing, sharing, and integration of computational thinking knowledge. It's a clear and ambiguous definition of core city concepts, and also it is a representation of tools, resources, learning context, as well as cognitive and effective dimensions. So our domain ontology methodology was based on semantic bottom-up approach, and it contributes to improve knowledge organization and conceptual coherence in computational thinking, and it offers a foundation for development of semantic tools and educational technology and enhanced collaboration and interoperability within the city community. And thank you for your attention.
A really good presentation, and definitely computational thinking is very vast domain.
Thank you.
And for that, we are working on ontologies, really great, something which we need at this moment. It is not a type of a query, but more like a my thinking point that if we thinking of computational thinking with, if we want to combine it with some learning app or a smart tutorial or tutor system, because basically computational thinking is being developed to develop something related to learning of or making learning easy. So
Yes.
if this is the thought, then if we merge it with, or if we combine it with agentic AI or something which is more reinforcement learning could be added, then it may enhance the application of computational thinking. For that, definitely we need more ontology work on such mix of domain. What is your state
Yes.
of thought in this context?
Well, I'm thinking to make a collaboration and a fusion between the field of artificial intelligence and computational thinking, because now the most used domain in the research is artificial intelligence. And I'm already started my after research of after getting my doctorate. So I still
It's
doing my
really
research. Yes.
yes, it is so state of the art today, because we know there are so many online tools and tutoring system available where computational thinking is applied. But the only thing is, it still struggle with the approach of reinforcement learning, where they just not give the idea, but also help students to learn it in a better way, specifically in context of programming. When we are talking computer science, we need some more advanced smart tools or softwares or tutors or agents that can guide students in much a better way. Definitely in that area, your research will definitely boom. You'll get a good
Thank you.
production in
Thank you.
that area.
Yes, thank you, ma'am. I'm thinking to, and I already prepared a systematic review about the use of computational thinking and the integration with artificial intelligence. I already found some research that they started how to integrate computational thinking with ChatGPT, for example, how to be
Yes.
integrated with or in the reinforcement learning, as you mentioned, ma'am. And
Yes.
I proceed my research, inshallah.
Definitely, I want to see your work with agentic AI, and definitely you'll
Inshallah.
do much, much
Yeah.
great work. Thank you
Thank you,
so much.
ma'am. Thank you. Thank you.
Thank you, Mr. Zazi, Dr. Sharma. Next, we have Yang presenting lattice scan, a polynomial Arnold model framework using lattice functions for regression and classification. Do we have Mr. Gangtang with us here? Okay, so our next and final presenter is John Mpesa Midedi, presenting robust complex signal classification for advanced software-defined radio and sensing. Do we have Johnny Mpesa Midedi with us here? Okay, so that is it for today's presentations. I'd sincerely like to thank all our authors for the excellent presentations and valuable contributions to this session. I also extend my gratitude to all participants for being a part of this international conference. I hope this session was informative as well as insightful. On behalf of the ICICT team, thank you for your continued support during the 11th edition of ICICT, as well as the previous editions. We look forward to welcoming you again for the 12th edition in 2027. All presenters will receive their digital certificates by email within 2 working days. The publication is expected to be available within 7 to 8 months. We kindly request your cooperation with the ICICT 2026 team during this process. I'd also like to thank our session chair, Dr. Amita Sharma, for effectively chairing this session. We now present a token of our thanks on behalf of the ICICT 2026.
Thank you so much.
May I now request everyone to please, just turn on the camera so that we can have a snapshot of the session. May I please request everyone to turn the cameras on? Thank you everyone for joining us today.
Thank you. Thank you.